To the stage for DevNation San Francisco 2016.
Wow, a decent crowd here this afternoon. Thanks for sticking around. Today was an amazing day for us. Did a lot of great things, a lot of great announcements this morning, and a lot of great sessions. And I want to thank everyone for sticking around. This morning we talked a lot of dev, right? We did a lot of developer tools, a lot of developer process, a lot of developer technology, but we didn't get to the DevOps part, and that's what this is all about this afternoon. So before I get started real quick, I want to thank everybody for the sessions too, for all the time and effort that went in today. I hope you all enjoyed all the different sessions you go to. Did you guys have a good time? I do want to know, did you have a good time? Yeah, all right, great. Okay, so without further ado, I'd like to welcome Rachel Laycock up to the stage from ThoughtWorks. Thank you.
Thank you. Hi, everyone. So I'm from ThoughtWorks. ThoughtWorks is a software consultancy. And what we do a lot of is helping clients, and have done a lot over the past sort of 5 or 6 years, is helping clients adopt continuous delivery. So what I'm going to do is tell you some funny horror stories of helping clients do that, and what are the realities of actually adopting these kind of practices in the enterprise. So I'm not going to explain what continuous delivery is, because a lot of people have done that before me. Some of my colleagues a couple of years ago wrote a book about it. But what might surprise you to hear is, even though we'd been doing continuous delivery before the book, which was written in 2010, I actually said to a client one day, you can't have continuous delivery. So let me tell you a story about how I got to this place, this sad, sorry state of affairs. And all good stories start with once upon a time. So once upon a time, I was a software developer in .NET for like over 10 years. I did a lot of continuous delivery stuff, and I thought I knew what continuous delivery was. I read the book. I kind of felt it like it was my duty as a thought worker. I was doing it on my projects, and I was regularly releasing to production-like environments and automating build and deployment pipelines. And then one day, a client, a big, large enterprise financial client, asked for continuous delivery because they'd read the book and they heard the benefits, and they were really struggling. They were on a very slow release cycle of every 6 months, and then a monthly hotfix. So they were on a recycle of every month. And by the time we rocked up, it was the third weekend of trying to get the hotfix out. And the hotfix required basically everyone, every skill, ops, dev, testing, the whole lot, to turn up into the office of the weekend. So by the time I got there, they weren't very happy. So they said, can we have continuous delivery, please? And I said, sure, why not? But 3 months later, everyone was like, are we there yet? We spent a lot of money on this. Do we have continuous delivery yet? Actually, a client executive shouted at me and said, where is my continuous delivery? He didn't have it. So how did we fail so miserably to not even implement some of the most basic stuff of continuous delivery? Well, they say you learn a lot from your failures, so I'm going to share what those were with you now. Because this was their biggest problem. Their code base was huge, complex. 70 million lines of code with millions of dependencies. Their architecture was, to be frank, a complete mess. And Jez Humble, who wrote the continuous delivery book and came down, didn't tell me about this. He didn't write this in the book. So we've all learned a lot in the post-continuous delivery world, and in particular that operationalizing software is actually very hard. And also learned that continuous delivery is quite big, because lots of people think it's just environments and deployment and build pipelines, but it's also data management and configuration management and continuous integration and quality assurance and architecture. Ooh, and don't forget about release management. And don't forget that you also might need to change your organization. So it's pretty big. And in most organizations in the enterprise, each one of these boxes is a different organization that are incentivized differently and measured differently. Sound familiar to anyone? Yeah, that's good. So I'm just going to talk about this bit right at the start that makes it really, really hard. So this is the new world that everyone's after, right? There's all these cross-functional teams using platforms, self-service platforms to deploy value to customers. So the old world of broken down silos is supposed to become cross-functional teams, just like magic. And this slow infrastructure that you have to submit tickets to get hold of is supposed to just become low friction and self-service. This is what clients keep asking us for. They're no longer asking for continuous delivery. They've also kind of stopped asking for microservices. Now they want containers, and they want self-service platforms, and they want PaaSes, and they want everything. They want to run before they can walk. Because CD was always about building stuff right and being able to deliver stuff rapidly that wasn't broken and didn't make operations people hate you, because they did hate us. And in fact, you work with them and you become partners and you call yourself DevOps. So what's in the way? In order to create platforms to deliver, you need not just technology, but also the right people and the right processes. So the things that are in your way are legacy technology, legacy processes, legacy people. No, not legacy people. Legacy organizational structures and management. I'm joking. Replace the people. No, jokes. So let's start with the easy one. Legacy technology. I didn't think I was going to say that was the easy one, but it is the easy one. And this one isn't easy. Anyone know what this is? You can shout if you want. Dependencies. It's the giant ball of mud, the most common software architecture pattern there is in the world. It's also the business systems of one of the largest financial organizations in the world. And in enterprises, you're likely to have hundreds of these. But even at startups, because I've also worked at startups, you have these too. Because at a startup, why would you build the perfect architecture of something when you don't even know if you're going to use it? It seems like a lot of waste of time, even though as developers, we are in the habit of sometimes over-architecting things and trying to create something perfect. But you don't know it's perfect if nobody's using it. So imagine the value that you want to deliver to your customers, or that your organization wants to deliver to its customers, is right here. This has two key problems. Just two, it has loads actually, but I'm just going to call out two. It's extremely hard to maneuver. It's slow and expensive to get business functionality out, and one change can have far-reaching impact. And it's very inflexible. But also, what's also very important about this is it's really painful and demoralizing for people to work in this. You also can't get the benefits of things like scaling and multi-tenancy when you've got this thing. I mean, what are you going to do? Just dump it on like loads and loads of servers and horizontally scale it all over the place? That's not quite what you're after. So the paper that Brian Foote and Joseph Yoder wrote, summarized in these 3 words, is that technical debt like this is caused by expediency over design. So we're busy getting features out the door and not thinking about the design. Or at least you would think it was that simple, but it's actually a little bit more complex than that. Because technical debt can be caused by many things. First of all, it could be like, we have to meet these certain compliance requirements. We have to ship now and just deal with the debt later. But you have to remember, this is debt. You have to pay it off at some point, and that's the part that people can kind of forget about in the metaphor. Your debt can be completely inadvertent, so you might have teams or developers or people that don't really understand the way that the system is supposed to be designed, the way that you've architected the system. Layering is a very simple example, but I can give you one that just happened to some developers on our teams just last year when we decided to implement a very large-scale event-driven architecture. That was quite a paradigm shift for the developers to go from their old way of developing software to a new way, and so they made mistakes sometimes and broke the paradigm down. So technical debt can be prudent or it can be reckless. It can also be deliberate or inadvertent. So if it's reckless and deliberate, and you decided to go down the agile path and throw out all the documentation, you say, we don't have time to design, we're going to do it later, we're going to do it together when we're developing it, or not at all. So when is a good time to design? It's the question we always get asked. Because obviously, over time, if you don't properly architect and design your software fit for purpose, eventually it gets harder and harder to add the features that you want. And the idea is that if you do nice, good design, then it's going to be easier to add features over time. But people always say, like, but when is a good time to do good design? We should probably be thinking about it all the time. But this is the biggest it depends question in software consulting. I don't know when is the right time for you to change the design of your software. It takes experience. It takes experience of going through lots and lots of different kinds of pain. But there is another kind of technical debt that gets created even when you're being prudent. And it's still inadvertent. Because now that we're doing things like continuous delivery and we're deploying software into production on a regular basis, we start to see how users are really using the software. And now we know how we should have designed it. You see, this is really tricky for engineers to talk about because telling like business people, like, sorry, we did it wrong, not because we were rushed, not because the team needed upskilling, not because we didn't have time, because we did it wrong and we didn't know how the users were going to use it. So what do? Well, the good news is now you have an opportunity to do something about it because every business is claiming that they're a technical business and they no longer consider us to be a cost center. Woo, we finally won. But they want to leverage the benefits of scaling and the efficiency of cloud. They want self-service platforms. They want to be able to deliver value faster to their customers. So this is an opportunity for us to tackle all this technical debt and get real about what that involves. But that technical debt actually comes down to two fundamental issues in software, engineering and design, that we just keep making the same mistake over and over and over again. Coupling and cohesion. For those that know what the technology radar is that ThoughtWorks produces, when we put that radar together, we often have heated debates about many things, as you can imagine. And we recently had a debate about coupling, and literally half the room was like, coupling is bad. And the other half of the room was like, well, it's a little bit more complicated than that. The thing is it's not actually good or bad. It always depends. It's a trade-off. You have to think about the life cycle of how the technology is going to be used. Now, to give you an example of bad coupling or coupling done wrong, I'll talk about an airline that was grounded for, instead of just a few hours because of an issue, was grounded for 24 hours because of the IT systems. Because what they'd done is they'd coupled their reservation with their boarding system in the database, because database integration was all the rage at one point. But they have a very different life cycle. So when people were at the airport trying to board the plane, people at home were kind of like, should I set off for the airport now? So they're like hammering the website, just keep refreshing, and eventually brought the database down, which brought the boarding system down, which meant that nobody could board the plane. So then this problem propagated. That's bad coupling, because that is actually bad coupling. Because when it comes to software architecture, it's really just the tension between coupling and cohesion and thinking about what's the life cycle of the functionality that you're trying to build, and also what's the deployment life cycle of that functionality, and then getting your heads together and thinking about where should you couple and where should you not, because you always have to couple at some point, because most systems are bigger than just one tiny little service. Most functionality is bigger than just one tiny little service. And the answer isn't microservices, by the way, because this is our latest silver bullet. That was some British sarcasm there. Microservices are not the answer. They are a post-continuous delivery architectural pattern based on a lot of things that we've learned around being able to automate and deploy infrastructure and all the things that we learned that didn't go quite so well in the SOA world. But the point is, it's something that we started using quite heavily at ThoughtWorks because it allowed us to deploy things independently and treat things as their own mini applications. And then we had containers and everything was awesome. But they don't solve the coupling and cohesion problem. In fact, they just make it worse. Because in a microservices architecture, you've actually moved the coupling from like in process to external and distributed, which has a whole host of other problems associated with it, which I won't even go into, because this is not a talk on distributed architectures. The point is what coupling actually, not coupling, what microservices actually provides is it forces you to think about coupling. And that's actually one of the things that I think the real benefit that it brings. Because people have to start thinking about, well, if I couple this to this service, then how do I deploy? And if I couple this to this service, will this break or will this break? But you're adding all this extra complexity around testing and eventual consistency and event-driven architectures and whatever else that you may come up with in order to figure out how to implement microservices. But the point is, in the microservices world, if you get the coupling bit wrong, it's a nightmare. Because the coupling issues become integration issues. And integration has never been something we're very good at either. We've still got a lot of lessons to learn there. So they don't solve the problem for you. They simply force you to be thinking about it because you have to be constantly vigilant against services that talk too much. You also now have to think about messaging and integration and communication and maybe domain design and maybe eventual consistency and a billion other things. So it's kind of a trade-off. But if you want the independent scaling benefits and the independent deployment benefits of microservices, then this may be a route that you want to go down. And there are patterns for moving from a monolith to a microservices architecture. This is the strangler pattern. You can read up on this. But the only really point that I want to point out here is if you go down this route and decide to start creating these mini modules all over the place and you stop halfway, halfway is actually much worse than the start. Don't just get halfway and like create an even bigger technical debt than you've already got. So with great power, the great power of creating distributed systems, which is what you've done when you've created microservice architecture, there is a great deal of responsibility. Because the other thing that I like to remind people of is that refactoring when you've got two separate applications is not super easy. And if you start duplicating services all over the place, you've spread that stuff all over your infrastructure. So it's kind of, I don't know, be careful. Because in 5 years' time, we're going to be like, what the F was that? And why did we think that was a good idea? Because microservices are a choice. They're not an answer. They're not the solution. They are a potential solution, which is something we seem to forget a lot about in our industry. But they are a current solution. So this was the easy bit, focusing on coupling and cohesion. That's the most important bit. But you can create the most beautiful architecture diagram you want. Once you involve these things, like people, processes, it all goes to poop places, not good. So you have to create the environment that supports continuous delivery and the architectural discipline, because a process or structure change doesn't really have lasting change. People don't follow rules. They're basically, even technologists, even as very logical, rational people, are like a very complex organism. And some days we wake up and we're happy, and some days we wake up and we're not happy. And sometimes we hate other teams, and sometimes we don't mind them. So the real elephant in the room is actually Conway's Law. I'm assuming most people have heard about this at some point, but even though we talk about it all the time now, I don't see many people really thinking about what does that mean to them. Because legacy organizational structures will destroy your beautiful architecture every single time. It'll also make your best people leave. And this is a quote from Michael Nygaard's book, Release It. And Release It is a great book if you haven't already read it, which talks about, the real issues around releasing software and scaling software and how do you implement circuit breakers and all this good stuff. And even he says you probably should design your teams around how you want your architecture to look. Now, one way to do this is to think about platforms, products, and services you provide and how they will be delivered. Because even with team structures, again, it's all about coupling. Sorry. Just about coupling. Because actually, when you start thinking about, well, how do I design my teams around the architecture I want, you come back to coupling again. So thinking about the life cycle of the platforms that you create, whether that's infrastructure platforms or experimentation platforms, some of the underlying infrastructure that you have in your organization, and the services that you create, and the products that you provide to end users, and throughout the whole architecture and the different services that you create in there, whether they're monoliths or microservices or whatever event-driven crazy model you come up with, it's all about the life cycle of how the customers use them, the life cycle of deployment. Just think about business capabilities. It's not whether you're a DBA or whether you're a .NET developer or whether you're a JavaScript developer. Customers don't care about that. Boarding and reservations are two separate capabilities. They may be supported by the same infrastructure platforms, but they're likely to be supported by different services and different databases. And you also have to structure the teams around that. Because you will always have some level of coupling. You simply cannot avoid it. And the last thing is ownership is also really, really important. Projects die. I'd like to call this platform, services, and products, not projects. But projects die, and when things die, they get entropy. And when you get entropy, you get debt. When you get debt, things are slow and expensive. And let's not forget all the other stuff that goes on in your organization. Political fiefdoms and silos, and basically every time I've gone into a large enterprise and started implementing continuous delivery, let's say about 80% of the time, I've ended up in front of HR. Why do I end up in front of HR? It's not because I'm getting fired. It's because people now have new roles and new responsibilities, and they need to be measured in new ways. Otherwise, they will subvert any beautiful picture we draw. So think about all of this other stuff as well. So remember these two things. Conway's law is the law. And when people talk to me and say, I'm adopting continuous delivery, and they start talking about cloud technologies and containers and infrastructure and DevOps and all this fun stuff, and I'm just sit there shaking my head because I'm like, what are you talking about? Because the only thing I need to know about your technology is how much technical debt you have, and where is it in relation to the capabilities that you want to build. And that isn't questions I ask business people. That's the questions I ask the developers. Because what people and process issues you have and the maturity of your organization to deal with them is really whether you're going to be successful in implementing any of this stuff. Because there is no silver bullet. There is no easy way to do continuous delivery retroactively. You have to focus on creating loosely coupled applications and create teams and communication structures that support that. And that literally impacts every part of your organization. So you probably shouldn't decide to do continuous delivery everywhere all at once. Good luck with that. So focus on coupling cohesion. Remember that Conway's law is the law. And finally, hope is not a design method. You have to be very intentional about this stuff. Don't get caught up in microservices. Don't get caught up in continuous delivery. Don't get caught up in containers. None of that shit's going to solve your problems. Intentional design, thinking about how things are coupled together, thinking about where you need cohesion and where you can get away with not having it. And then you might be successful at implementing continuous delivery. Thank you.
Thanks, Barbara. Rachel. So as you take that journey to transforming your environment into a more DevOps-focused continuous integration environment, we've been working in the developer group to think about how we kind of bring that together. And one of the kind of underlying technologies that we have at Red Hat is the work that we do around container orchestration specifically Kubernetes. And the product that we have that supports that is called OpenShift. And it's one of the products we've been working on a lot over the past few years, and it's really it's quite remarkable. And to talk more about that, I'd like to invite Ashesh and Matt up to speak more about that.
Cool. Thanks, Harry. So Rachel did a great presentation. I'm feeling so bad I'm following her. She's got an accent, sounds like it's English. So I don't have jokes though, like she had. I could make jokes about the English today and soccer, but I won't. Or football, right? That's what they call it. I won't. I said I won't. I said I won't. I could make jokes about the English and the European Union, but I won't, right? Instead, I'll go to less controversial topics and talk about OpenShift. So my name's Ashesh. Thanks very much for hanging around, staying. I did tell Harry that the next time we do this, we should serve beers to sort of get more people to hang around. So Harry, that's actually something the English would support, I'm guessing. Matt Hicks is next. Matt's definitely funnier than I am. Matt runs engineering for OpenShift and management and developer and a lot of other stuff. So he'll come talk some more, and then we'll of course have David from Google. So I don't have jokes, but I have questions. So let me run through some questions for you. Question is, what is OpenShift? So if you're like, strange question, why ask that? Well, that's because we seem to be a lot of different things to a lot of different folks. A, is it a container-based cloud application platform? That sounds like a mouthful. That you can deploy on physical, virtual, private, public clouds? Possibly. Does it support, we had Rachel talk about this, and I guess Harry and the rest of the folks, they've been talking about these microservice-based architectures, enabling middleware services to run on them. Can it be consumed as a public or dedicated cloud service or privately administered and managed by folks in your organization? Is it a PaaS? Is it a CaaS? It's like a Superman movie now. Can it be used by developers, by enterprises? Or E, is it all the above? So obviously the answer is all the above, right? It's being used as a platform as a service. Lots of folks have been talking about what CaaS is, a container as a service. We've had developers use this at scale. I'll talk about that as well. And large customers all around the world. I've listed some, but if you are sticking around for Red Hat Summit over the next few days, I encourage you to go visit. A lot of these customers are here talking about their use of OpenShift, as well as other customers, right, like Airbus or Swiss Rail and what they've been kind of doing with it. So definitely go check out their use cases. But like I said, right, let's talk about progress, right? So from a developer perspective, we've had over 3.1 million apps deployed on the platform since we've had OpenShift around. So that's since 2011. Adding lots of users every week, right? So over 6,000 users being signed up. Got a couple thousand new applications landing on the platform every day, and over 4 billion requests a day that we serve out. Also really proud about OpenShift Commons, which is our essentially free-to-join community for folks who want to share best practices about deploying containers, running containers at scale, learning about the best practices around developing and deploying and managing a platform as service offering, and really all kinds of organizations, users, developers, enterprises, not-for-profit, universities have joined OpenShift Commons. So encourage you to go check that out and sign up for that if that makes sense for you. So why are we here talking about all this, right? So Harry said, hey, look, we've started this conversation today talking about developers. We've gone to talk about DevOps. We'll spend a little bit more time talking about DevOps and Ops and really some best practices around how you think about application development and deployment, but also about how you manage your processes and run and manage infrastructure you have. OpenShift around 2014 had been adopted pretty significantly, had lots of traction with customers and users, and our version 2 technology at that time was being well perceived, but the space was fragmented. By that, I mean if you want to extend out the platform and run software on it, right, you had to essentially do something called build cartridges for OpenShift. And then there were build packs, and then there was Amazon Machine Images for the AWS platform, and so on and so forth, right? So the space was fragmented. When people wanted to use software, they had to package up in different ways to use it and leverage it. And then, of course, as you go across platform, that breaks. Docker had been out for a few months, right? And we kind of see the promise around that. And we said, well, this is an opportunity for us to converge a single container format and a runtime around that. But once we did that, The next question was, well, how do we manage these containers at scale, right? How do we manage the clustering that happens around with this? How do we manage the health of these containers that we run across different environments? And that's where really Kubernetes came in, right? So that's kind of the part of the journey that we've been on, about thinking about if we want to run these, manage these, be able to manage state, be able to figure out if we're going to put this in our own data centers or run this in a private or public cloud, or what people call hybrid clouds. Right, we've got to be able to solve this problem and be able to solve this at pretty large scale, and then be able to continually increment upon that. Now, of course, it's hard to do that on our own, right? And obviously, it's difficult to do that if you don't have a community around you. And so us thinking about participating in a wider community, right? So if you're a user or a customer, you don't feel like you're locked into a single vendor solution. It's really important. Participating with several other organizations, adopting the Docker technology as part of the Open Container Initiative, is something that we stand by. We invest a lot of our time and energy and our engineering resources to help drive forward. The same is the case with the Kubernetes community, and we'll talk a little bit more about what that means for us. And obviously, investing in the Cloud Native Computing Foundation. It's not just us, right? It's a lot of other companies, right? So definitely Red Hat, right? But it's also Cisco and Intel and IBM and Huawei, and of course, Google that's been leading the charge around this. But to tell you a little bit more about the journey we've been on, I want to bring up Matt Hicks.
Thanks, Josh. So this was a pretty good spot to be in, right? We had the industry adoption. A lot of people have probably heard about this technology. But I think one of the most important parts is actually to look at the problem that Kubernetes was there to solve. When you look at container orchestration, we really had to shift into this mindset of how are you going to describe either a modern day application or one of the thousands of applications that you're running today. And Kubernetes introduced these building blocks, things like pods to describe container colocation, and services to take a bunch of those pods and describe how are you going to access them at a network level. Or replication controllers to describe how many instances of those you wanted and how scaling was going to work. Really gave us that language, that vocabulary, where we could take this great, very exciting concept about containers, start stitching them together to actually form applications. And if that was Kubernetes 1.0, which we were really excited about, the best part is the pace of the project and capabilities has continued to increase. If you look at the last release, Kubernetes 1.2, which is what OpenShift today is based on, you saw a humongous increase in scale and capabilities. You saw application configuration greatly improve, which meant more applications you could actually represent in this model. Then you saw things like the new scheduling features and extended schedulers, which meant different workloads closer to Mesos or batch-like patterns that you could run. So the project didn't only give us a great foundation to work with, but it has been increasing and innovating at a tremendous pace. So with this combination of stuff, we now had the pieces that we could build the next generation of OpenShift on. We had the runtime, we had the container format, we had container orchestration. That got us back into our sweet spot. We started to get into those areas of how do we now give prescriptive patterns on building continuous integration and continuous deployment around Jenkins workflows and being able to establish those pipelines. Then when we talk about deployment, how do we make people not resolve the same problem for the 1,000th time and give them blue-green style deployments or canary deployments or even A/B deployments where you can split network traffic on them? Then you go one level up and say, all of my developers don't want to understand how to build layered containers right. How do we build in that automation and bring that all the way to the developer tooling? And then lastly, when you're running this at scale, how do we give you operational management where you can't just view the container layer, but you can link that to your VMs and you can link that every step down to the physical hardware. So that to us really gave us this vision around our container platform. That's where we started in OpenShift 3.0. We've continued to advance as we go forward. When we talk about something like OpenShift, it's not just integrating this technology. We work differently. We really get involved in the communities themselves. So if you look, great examples with Kubernetes. One of our needs, as Shesh mentioned, OpenShift Online and running millions of applications. multi-tenancy was pretty important for us. We had to be able to separate customers from each other, both in a functional area as well as the resources that they got. This work allowed us to drive capabilities upstream in Kubernetes like the namespace capabilities as well as quotas and limits. But then we also looked to our enterprise customers who they were running applications, stateful applications against storage that they had on-prem today. That let us help drive the volume functionality and implement storage plugins ranging from NFS and iSCSI and Fiber Channel all the way to new Ceph, Gluster, and even cloud-based storage. But most of you probably know, like this is how Red Hat works. This is what we do. We are also able to extend this model to our customers. Probably one of my favorite things about being at Red Hat. Now, Amadeus has been a great use case of this because Amadeus last year, when we announced OpenShift 3.0, they announced they were betting on the OpenShift 3 platform, right when we first started talking about it. And the reason was they had been working with us upstream in these communities before we'd even GA'd the product. That collaboration led to capabilities like job support in Kubernetes. This is forming the basis of scheduling and eventually batch and Mesos-like workloads in Kubernetes that started with our first requirements with Amadeus. OpenShift and OpenStack, they're a huge OpenStack customer. They run OpenShift on top of it. They didn't just take the products and the integration we provided. They continued to improve that and actually became one of our primary contributors to the installation and integration we carry there. And then lastly, if you look at some capabilities like syscontrol, not sure how many people know about this functionality, but you're a C++ developer and you use shared memory. At the time, running a C++ application in Kubernetes, that was a little bit bleeding edge. There weren't a ton of people doing that. And Amadeus had that requirement. We worked with them for over a year to build this into all the various layers in the stack. When we were done, huge benefit to Amadeus because now they have their application they could run in this model. But then it also ended up being a huge benefit to all the other communities and a really, really exciting feature. So this was a neat way where we were able to take our model, our way of working in the open and open innovation and extend that to our customers as well. But before people knew about Kubernetes, and we were talking about this and all excited about it, it really started as a bet for us. Back in history, this was sort of our gamble when we knew we were going to bet on Docker and we were having this conversation of what should we do in the orchestration space. A great technical partner of ours, Google, had this idea. They were going to take a lot of their knowledge because they'd been running on containers for a long time. And they were going to open source that project. And they really wanted us involved from the beginning and to bet the next generation of our platform on that technology. And now looking back, I'm extremely happy we made that gamble. But it's not just because the technology is great, but I think Google has built a world-class open source project and ecosystem around this as well. To talk with you a little bit more about that, I'd like to introduce David Aronczyk, who runs product management for Kubernetes from Google. David?
Thank you. Thank you very much. Thank you for the opportunity to come and talk. So it's interesting because we at Google, when we first got this going, had to make almost the exact same bet, but in reverse. When you're starting a project like this, the first people that you bring into the project are some of the most critical. They're the ones who help architect, who set the culture, who set the mentality for how you're going to go about this project. What's in, what's out, so on and so forth. And while we're in the midst of sorting through that, we're also moving 1,000,000 miles an hour, checking in massive blocks of code and things like that. One of the best earliest signals we saw when we were building Kubernetes was senior Red Hat engineers pointing out, Go hygiene mistakes that we were making. These were people who actually cared, not just about the project as a whole, that we were getting the right features in, but that we were also building something that would be maintained over its entire lifetime. Now, they haven't just gone forward and made sure that we indented properly. They actually had, they continue to add core features to the product and make huge improvements, whether or not it's fundamental things like persistent disk. We already talked about jobs. Some of the Red Hat engineers were some of the ones that will be invested in huge features coming up around improved support for stateful services. So It was a big bet at the beginning, but I think unequivocally we can say we made the right one. As far as the Kubernetes project as a whole is concerned, for those that don't know, it is obviously an open source production-grade orchestration system, built in the same way that Google does it internally. One of the most fundamental goals about Kubernetes is the ability to run anywhere. So it's not just a Google project. It runs on bare metal, on VMware, on Vagrant, on AWS, on DigitalOcean, on Azure, you name it. And most importantly, it allows people to deploy it in the places that make sense for them, where you can now run additionally things on top of it, such as OpenShift. So basically, our goal is to have this very clean platform that lets other people go off and build huge businesses on top of it, exactly as Red Hat has done. We have broad industry support. We already talked a lot about that. Red Hat is certainly a leader here. And as a whole, we've counted up over 233 person-years worth of contribution, and that is in just 12 months since we GA'd. Actually, technically 2 years since the first check-in. But very, very young project to have that much momentum behind it. In the coming days, we will be announcing Kubernetes 1.3, again with enormous help from Red Hat and many, many others in the community. Here are just a few highlights. The first is around scaling. We've doubled the number of nodes supported on the Google Cloud. On premises, we see people going even higher, but with a 99.95 SLA on the Google Container Engine, we support twice as many nodes as we did it just 3 months ago. We've made massive improvements around stateful application support. One of the biggest problems that people have when approaching containers today is how you migrate in and manage things like state. Built in as first-class object is the new pet set object, which will help you manage state for things like databases, key value stores. We have a significantly improved local developer experience. So on your laptop, with one command, you can spin up a Kubernetes cluster and begin building and testing just like you would with any other container system. We have automated integrated cluster scaling. So Kubernetes will watch your cluster and see whether or not you have pods that need scheduling and go out and request more CPU, or if you're not using that CPU anymore, it will naturally scale down as well, making sure you're staying within your efficiency and utilization guidelines. We have brand new support for container standards. One of the most fundamental things about open source is allowing people to choose. We'll be supporting Rocket, OCI, and CNI in the box. So you can choose the container system that makes sense for you. We have integrated support for cross-cluster federated services. Again, one of the most common things is people want to set up multiple clusters in multiple availability zones, bridge on-premises and cloud, and integrated into the box will be federated services so that without any additional work, you'll be able to deploy services and spread your load across those different clusters. And finally, thanks to Red Hat and some amazing work that they did, porting back work that was in OpenShift, we have a significantly improved identity and authentication management system in the box, allowing you to have greater control over the way that you interact with the cluster. So those are just a few of the things that are coming in Kubernetes 1.3 due out momentarily. And with that, let me pass that back.
So it's been a great day. It's been a long day. But if you're interested in learning more, I know that some of you have actually registered. We have a code starter tonight to actually get hands-on with some of the Kubernetes stuff that Dave just showed you. If you're registered for that, just a reminder, it starts right after this session in the room next door. I hear there's a couple seats available still, so if you want to try to squeeze into that, you're more than welcome to try next door. There's another thing I want to announce, which is a hackathon. It's a hackathon that the OpenShift team is doing. It's a 12-week online hackathon. It gives you $500 in OpenShift online credits for the first 200 submitters, and over 40,000 in cash prizes are potential to win. If you're interested in that, you can go to openshift.devpost.com and registered for that today, right? Today. And also, tomorrow begins the official Red Hat Summit. So everyone go out and have fun tonight, but don't have too much fun, because starting at 8:30 tomorrow morning, we have the keynote starting in Hall D. And hopefully we'll see all of you there tomorrow and have another great day. Thanks everyone for being here.